Hi everyone, welcome to Byte and Beyond with Uday. In this video, we are going to learn about dependency inversion principle. So let's begin. So it is one of the principles from solid family, and what exactly it says? It says high level module should not be depends on a low level module. So over here, if you see this slide, this is the example of bad design. So if you see over here, this is database service, this is higher level module, and mm, here is the MySQL database. All right, this is another class. So if you see, database service is a high level module, and MySQL database is a low level module. So database service is directly depends on the MySQL database class. All right. So if we read this line, high level module depends directly on low level implementation. So MySQL database is low level and database service is a high level. So when this type of scenario occurs, at that time we ending up with the bad design. I will explain you why this is the bad design. All right, with the practical example. So basically, when we talk about dependency inversion principle, it says higher level module should not be depend or should not be directly depend on the lower level modules. Instead of that, they should depend on the abstraction. All right. This definition will get clear when we see the when we will see the good design example. All right. But now let's see or let's focus on the bad design first. So what happens or what are the cons when we do not apply or do not follow the dependency inversion principle? So let's take the same example. So over here we have three classes, I would say. First one, database service, and we have two classes. One is MySQL and another one is Postgres. All right. So let's see the bad example in our IDE. So if I expand this, as per the slide, you can see this is database service, and database service is directly depend or directly using the MySQL database, right? And MySQL database class has few methods such as save, update, delete to perform this type of operation in the MySQL database. All right. So as per the slide, we can see database service directly depends on the MySQL database or directly using the MySQL database class. All right. But at looking at this class, we don't see anything wrong over here. Yeah, even I can say there is nothing wrong over here by looking at the class. But when the situation gets tougher or gets different, all right. So if we see the slide, database service directly depends on the MySQL database. Till here, everything is great. There is no problem at all. Now let me just run this class. So we have database service, all right, database service, and database service has few methods as we can see save, update, and delete. But internally, it basically using the MySQL database. All right. So let me run this class. Let me run this main method and see what happens. It basically calling MySQL database methods, save, update, delete, and operations are also being performed perfectly fine. There is nothing wrong till now. All right, there is nothing wrong. All right, I was able to run these classes. I mean, run this main method, and I was able to execute all of the methods of database service and the MySQL database class. So if we see, these are the sysout statement that we can see in the console. All right. So now let's say, now in your application situation get changed, and suddenly stakeholder has decided to move on to the PostgreSQL. So meaning, in simple language, instead of MySQL, now your application wants to use PostgreSQL. So what you will do? So what you will do? You will create another class. For example, Postgres database. And over here, you will connect to the Postgres database and perform this type of operation. So you can see this type of method: save, update, delete. All right. But but I have created this class. That is perfectly fine. That is needed. But if I need to, if I need to, if I need to connect this database service with the PostgreSQL, I need to change this class. I need to make modification in this class. So when we make modification in the existing class or in our existing logic, we might ending up creating new bugs, or it is a tedious task to change this type of things in our application. I mean, it requires a lot of refactoring and regression testing or smoke testing. All right. So there is a unnecessary hassle when we design our classes or our software like this. This is literally unnecessary hassle. All right. So now I need to switch to PostgreSQL database. So what I will do, instead of MySQL, I will use PostgreSQL. All right. You can see PostgreSQL, Postgres database. And I want to update this variable as well. All right. Postgres database, let's say. So you can see I have updated this constant of Postgres database, and I have updated the variable name MySQL to Postgres database. Now let me execute this tester class to execute our database service methods. Let's see what happens. So now instead of MySQL, we are using Postgres database. You can see saving data to Postgres database, updating to Postgres database, and deleting data from Postgres database. So the problem over here is, whenever we are switching to the different database, I need to modify this database service, and that requires refactoring. And when we refactor, we need to do the lot of testing. It can be regression, smoke, all right, regression testing or smoke testing, all right, unit testing. So these are unnecessary hassle. Why? Because we haven't designed our application using the solid principle. In this case, we are breaking the dependency inversion principle, because our higher level module, this is database service, our higher level module directly depends on the lower level module, which is MySQL database. Now, if I need to switch to Postgres database, I need to modify this database service. This is unnecessary hassle. Why we ended up in this situation? Because we didn't follow the dependency inversion principle. Now, let's say in future, instead of Postgres, our our stakeholder has decided that now we are moving to the MongoDB. All right. Again, Again, in that case, again, I need to change my database service. This is headache. Every time we are changing the database, I need to make modification in my database service, and that is completely unnecessary. And this is, I mean, we ended up in this situation just because we didn't follow the dependency inversion principle. All right. Now we understood what will happen, or in what situation we will get end up when we do not follow the dependency inversion principle. But now what is the solution? All right, let's talk about solution. Everybody talks about the problem, but now let's talk about the solution. How can we solve that? How can I make my application, what changes I make in my application, so whenever, even if I'm switching to different databases, I do not need to change my database service. All right, so we will focus on that. Let me undo these changes. Let me close this. um what I will do, I will just I will keep it as it is. It is not bothering us, so close all tabs. All right, let's keep this as it is. And before I start coding for the good design, we will understand what exactly the good design looks like. All right. So over here, what again I will reiterate to the dependency inversion principle definition. So it says higher level module should not be depend on the lower level module. The higher level module should depend on the abstraction. All right, that's what the dependency inversion principle says. The higher level module should be depend on the abstraction instead of the lower level module. So if you see over here, this is database service. All right, and it has these three methods. Database service will remain as it is. All right, we will make only slight change inside our database service. I will let you know what exactly it is. Then we will create um, one more thing, which is an interface. So what I will do, I will create an interface. Let's call it database interface, and it has three methods. Whatever operation we want to perform, in our case, we want to perform three operation in the database: save, update, and delete. So this interface has three methods: save, update, and delete. Now these concrete classes, such as MySQL database, Postgres database, going to implement this interface. All right. So MySQL implements database, Postgres implements database. I will show you what exactly benefit it brings. All right. So this concrete class is this database class is going to implement this interface. So now what happened? Now our higher level module, our database service, do not directly depend on the lower level module. This MySQL, PostgreSQL, and whatever future database class we are going to create. These are the lower level modules. So by looking at this slide, you can see our database service is not directly depends on the lower level module, but now our database service depends on the abstraction. Database, this interface provides is the provide us an abstraction. All right, abstraction is one of the I would say very important feature of the ops concept. I hope you know about that. All right, so now our database service directly depends on the abstraction, which is database interface. So now we are following the dependency inversion principle. So what it says, high level and low level module both depends on the abstraction. So this high level depends on the abstraction, and this low level module also utilizing the interface, or we can call it abstraction. So now we are following the dependency inversion principle. Our high level module depends on the abstraction instead of the lower level module. All right. So how we are going to solve this problem? By just adding an interface. I will show you. All right. With the same example. So let me create one package. All right. Let's say, sorry, I was about to create a package. Uh, just a moment, huh? a good design. All right, good design. Now, as usual, I am going to create database service. All right, perfect. Now, I will keep it empty at this moment. One more thing I am going to create. I am going to create an interface, an abstraction, I would say, which is database. All right. Now, inside this interface, as per the slide, you can see it has two methods, save, update, and I mean three methods, save, update, and delete. So I am going to create this method, save, update, and delete. You can see save, update, and delete. Three methods we have. Perfect. Now, what I am going to do, I am going to create. All right. Now I am going to create. I'm going to create these concrete classes. All right. I will touch the database service in the end, but let me first create this concrete classes. Let's first pick up the MySQL database. All right. So let me create MySQL database. Okay. I'm going to create MySQL database. All right. And as per the slide, I am going to implement this database interface. And when I implement this database interface, I I have to implement all these three methods in my concrete class. So you can see I am implementing all these methods which are declared in the interface. All right, I have to. And I am writing my own business logic over here. I am connecting to the MySQL database and saving my data. Over here, I am updating my data, and over here, I am deleting data. Similarly, I am going to create one more class, which is, you can guess, another database, let's say PostgreSQL. I would say Postgre database. Let's keep it short. Again, um, instead of Postgre, it is showing suggestion or to have a better name. So I will keep it Postgres. All right, Postgres. Similarly, this class is also going to the implement the database. I mean database interface. So you can see I'm using GitHub Copilot generative AI, the coding assistant. So it basically gives me suggestion, and I'm just hitting the tab, and these methods are going to implement. It basically saves me to type keyboards. All right, so it saves my time. Yeah, come to our topic. Back to our topic, I would say. So Postgres database also implements the database interface, and you can see over here, similar to MySQL database, it is implementing all the interfaces methods, and it is writing its own logic, saving data to Postgres, updating data to Postgres, deleting data from Postgres. All right, these are typical methods. Now, our real part comes, database service. All right. So what will database service do? Database service will do something like this. Let me declare private. Let me make it final for now. Database. I'm going to create a constructor. All right. This is the constructor, and database has its own method, save, update, and delete. And internally, it is calling this interface methods, database.save, database.update, database.delete. All right. So you are might thinking earlier we were using concrete classes, but now we have replaced concrete classes with an interface. In our case, this is interface. So if I click on it, I go to the interface. But you are might thinking, interface has no logic. So how this exactly going to work? So if you might have noticed, this interface is implemented by these two concrete classes. MySQL, Postgres. All right. So I can use these classes. I can pass these classes via constructor. Let me show you. All right. So you get the better understanding or you get the better idea. Let me create a tester class. I will name it as good tester. Okay. And, this is the, what I can say, our main method. And these are the suggestion from the copilot. You can see I have created a concrete class. I mean, MySQL database, you can see I'm using database interface as a variable. And this is the concrete class. I'm creating an object of new MySQL database. Why this works? Because MySQL database implements the database interface. So I can use the variable of type database interface and I can create an object of type MySQL database concrete class. Now, once the class is created, what I am going to do, I am going to pass this object inside inside my database service constructor. So you can see this accepts one argument. So whenever I create database service, I need to pass an object. If I don't pass, it will give me an compilation error. All right. So let me just instead of creating new one, let me just remove. It will give me the compilation error because this requires this constructor database service requires an input and which accepts the database interface or type of database interface. So in our case, MySQL database implements the database interface, so I can pass the MySQL database object. So what I will do, I will simply pass the MySQL database. All right. For now, let me just comment it out just to make it clean, I would say. All right. And I don't need this. All right. I don't need this. So if you see, created MySQL database object, passing it to the database service constructor, and I am just calling. Let me just name it to database service instead of MySQL. All right. Now let me just run this class. Let's see what happens. You can see saving data to MySQL, updating, deleting to MySQL. All right. Now, let's say as per our earlier example, stakeholder or our team or our product owner has decided to move from MySQL to PostgreSQL database. All right. So how that is going to work? So what I am doing over here, you can see I have just created Postgres database object. You can see this points to this Postgres database concrete class, and it is also implementing the database interface. All right. And I just need to, I am not making any changes. You can see I am not going to touch, I am not going to touch a single line inside my database service. All right. So let me go back. I am just going to pass this Postgres database object to database service constructor. All right. And let me just hit the run and you will see the magic. Without changing a single line, we are switching to the Postgres database. All right. We haven't changed a single line inside the database service. You can see I haven't touched anything inside the database service. And you can see now we are switched to Postgres database, saving, updating, deleting data to Postgres database. And you have observed I haven't changed anything inside the database service. I have just passed or I'm doing constructor injection, I would say. I'm doing constructor injection. I'm injecting database all right, via constructor, and I am using it. That is it, nothing else. Now again, if I need to switch to MySQL database, so if I run this, you already have seen it, but let me show you again. All right, Postgres database. Now, if I want to, let me, slightly move like this. Okay, perfect. If I want to switch to MySQL database, I can easily switch it. You can see MySQL database. Now, let's say in future, new requirement comes and our application now switching to the MongoDB. Let's say MongoDB database. All right. So what I am going to do, MongoDB database. All right. And you can guess this class is this class also going to implements, all right, this class also going to implements that um, that database interface. All right, it has implemented database interface. It has implemented all of these methods. All right, now if I need to switch my application to MongoDB database, I can simply create an object of MongoDB database. All right. Let's say Mongo database. And instead of MongoDB database, you can see I have created this object and I will just pass this object to the database service constructor. I am not changing anything in database service constructor or database service class. I am just passing an object of Mongo database or MongoDB database. All right, and I will just hit the run button, and you can see the magic saving, updating, deleting data to the MongoDB database. All right, so it saves a lot of time of developer. Uh, Now, if in case of we are switching to the database, or it can be applied to anything. It is not related to database only. So let's take an example of different payment methods. All right. Let's take a example of payment methods. Let's say I have a payment gateway that accepts multiple payment types. For example, UPI, net banking, credit card, debit card. All right. Now I want to make my payment gateway capable that by just passing an object, it switches to that particular payment method. So if I need to, let's say this is UPI, for example, this is UPI, all right, and this database service is my payment gateway, let's say, all right, hypothetically, all right. So if I need to use UPI, I will pass this UPI object to this payment gateway, all right, inside this constructor. If I need to use, let's say, credit card, all right, credit card. I'm just giving another example where exactly you can use it. It is not, uh, tightly coupled with the database concept, but this pattern, this principle can be used at uh, in multiple situations or in multiple use cases. All right. So if I need to pass the credit card, if customer has chosen the credit card type payment. So this is, let's say, this is credit card, and I will just pass this object to the constructor. Now let's say net banking. All right, this object is the net banking. All right, net banking. So I will just pass net banking object to the payment gateway constructor. So same concept can be used in multiple use cases. This is not related to database, but whatever components whatever components we need to switch at the runtime, we can use our dependency inversion principle. This is basically combination of dependency inversion principle and strategy design pattern. All right. If I go in depth, so this is the combination of dependency inversion principle plus strategy design pattern. All right. So yeah, that is it for this video. I hope you have learned something new today. And I will put this link. This if you like to see the source code, I will put the GitHub link inside YouTube video description. So please look at it. And if you find my video useful, then please like, share, subscribe, comment. See you in the next video. Till then, goodbye.